A very good evening to all of you. I am Dr. Smita Mojumdar, Assistant Professor from Department of Chemistry, Techno India University, Tripura. Today I would like to discuss a topic which is basic spectroscopic techniques. Now, the introduction of spectroscopy. So, first of all, we would like to know what is spectroscopy. Spectroscopy is a branch of science where the interaction between the electromagnetic spectrum and the matters, that is particles, is recorded. And now electromagnetic spectrum, if we arrange all the electromagnetic rays like radio waves, microwaves, infrared, visible light, ultraviolet ray, X-ray, gamma ray, etc. according to their energy, wavelength and frequency, we will get a spectrum like structure which is known as electromagnetic spectrum. Now, what is the importance of electromagnetic spectrum? Actually, by using all these rays, we can manufacture different types of instruments which are very much useful for our daily life as well as in various scientific purposes. And before starting spectroscopy, we must know what is wavelength and frequency and the relation between the energy with wavelength and frequency. Now, introduction to spectroscopy. What is atomic spectroscopy? This is actually related to atom. Whenever we give any energy to any atom, then it will absorb the energy and the outermost electron will absorb this energy and go to the higher excited state, and which is known as absorption spectroscopy. Means the related spectroscopy is known as absorption spectroscopy. And again, when the excited electron will come back by emitting the radiation, it is called emission, and the spectroscopy related to emission is known as emission spectroscopy. Now, molecular spectroscopy, like atom, molecules also can absorb energy and they can emit and radiate energy. But also there are different types of process like vibrational spectroscopy, translational spectroscopy, rotational spectroscopy, which are not included in the atomic spectroscopy. So molecular spectroscopy is related to all these four types of spectroscopic method. Now, different types of spectroscopic techniques are used like UV visible spectroscopy, IR spectroscopy, NMR spectroscopy, mass spectroscopy, XRD, Mosby spectroscopy, etc. In this PPT, we will discuss UV spectroscopy, IR spectroscopy and NMR spectroscopy. Now, first of all, we need to know what is selection rule. The selection rules gives us the allowed the forbidden transitions of different types of spectroscopy. Like for UV visual spectroscopy, del J equal to plus minus del L equal to plus minus 1 is the selection rule for UV spectroscopy. For IR spectroscopy, del V equal to plus minus 1, and for rotational spectroscopy, del J equal to plus minus 1. So obeying this selection rule, the intensity of the spectroscopic peak will be determined. Now, UV visual spectroscopy, it is also known as electronic spectroscopy. It ranges from 200 to 800 nanometer. It is called UV visible spectroscopy because the total range is merged with the visible range also. And the UV spectrophotometer is used to predict the peak position. Now, what is chromophore and auxochrome? Chromophores are the functional groups, mainly the unsaturated functional groups, which include the color to any compound. And for example, ethylene, carbon-carbon double bond, carbon-carbon triple bond, C double bond O, all these are the examples of chromophore. And auxochrome, it cannot impact the color, but it increases the intensity of the chromophore. For example, CH3, NH2, all these are the example of auxochrome. Now, Lambert-Beer's law, which is very important in spectroscopy, it determines the absorbance the relation between the absorbance and the concentration of the solution according to Lambert-Beer's law. Absorbance A equal to epsilon C L, where C is the concentration of the solution and L is the path length. Now here I have shown one UV spectroscopy of a compound. Now there are different types of transitions, that is sigma to sigma star transition, pi to pi star transition, n to sigma star and n to pi star. These four types of transition is found in UV spectroscopy, from which we can predict which type of functional group or which type of compound it is, mainly the saturation and unsaturation, and which type of solvent is used in the solution. We can predict from the UV spectroscopic method. UV spectroscopy is also related to fluorescence and phosphorescence. Fluorescence, if any transition happens within the 10 to the power minus 6 second, then it is called fluorescence, whereas phosphorescence, it occurs with a long time lag. For this reason, after absorption of light, phosphorescence has been found to show its radiation after about 6 to 8 hours later. And for fluorescence, whenever we use the source light, then only we can see the fluorescence. Now there are different types of factors which affects the UV spectroscopy. One is bathochromic shift, hypsochromic shift, hyperchromic shift and hypochromic shift. All these are the prediction of the UV peak positions, and apart from this, solvents and the concentration of the solution, temperature, these also vary the UV transitions. Now bathochromic shift is also known as red shifts, and hypsochromic shift is also known as blue shift. This is the Jablonski diagram showing the fluorescence and phosphorescence method. In fluorescence, there is singlet to excited singlet transition happens, whereas in phosphorescence, singlet to triplet transition happens. Here, the UV spectrophotometer, how it works, is shown. Now, IR spectroscopy. It is also known as vibrational spectroscopy, which ranges from 400 to 4000 centimeter inverse. And the types of vibration, there are two types of vibrational spectroscopy. One is stretching and another is bending. Stretching is related to bond length change, whereas bending is related to bond angle changes. So there are different types of stretching and bending vibrations. Stretching vibrations, asymmetric stretching and symmetric stretching, whereas bending are scissoring, rocking, twisting and wagging. There are four types of bending vibrations. Now what is fingerprint region and functional group region? In IR spectroscopy, we have two regions. The fingerprint region is very much important to identify any compound, because in this region each and every type of compound gives a particular signal, whereas in functional group region we will get a particular signal for each type of functional group, from which we can predict that which type of functional group is present in this compound. Now it is a 0 point energy. 0 point energy, whenever a molecule is in its ground state, then also it is in vibrational mode. So the energy in its zero vibrational state is known as 0 point energy. This is the instrumentation of IR spectroscopy. Different types of source light source is used in IR spectroscopy, and here is the grating filter and recorder and detector. Now the fundamental modes of vibration. There are two rules. One is for linear compounds and another is for non-linear compounds. For linear compound, the rule is 3n minus 5, and for non-linear compound, the rule is 3n minus 6. N is the number of atoms present in any molecule or compound. there are different types of IR vibrational spectra like overtones, hot bands, Fermi resonance, and coupled vibration. The fundamental vibration is V0 to V1, which is very common to all compounds. For overtones, from 0 to 2 vibrational state, and hot bands are V1 to V2, V1 to V3, all these are the hot bands. Factors affecting the vibrational frequency: conjugation, inductive effect, resonance effect, ring strain, hydrogen bonding, all these can affect the peak position of the IR spectroscopy. Now the application of IR spectroscopy. So IR is used mainly in the forensic science to identify any kind of sample, and for chemistry it is also very important to predict the structure of any compound. For medicinal chemistry it is also very important for drug designing. Like this way IR spectroscopy is very much useful. Now the NMR spectroscopy, it is mainly the interaction between the electromagnetic radiation and the nucleus. So all the nucleus are not eligible to run the NMR spectroscopy. There are some rules which nucleus are eligible for studying the NMR spectroscopy. Generally 4 to 900 megahertz radio frequency is used in NMR spectroscopic method. There are two relaxation process. One is spin lattice relaxation process and another is spin relaxation process. Now there is two field in NMR spectra. One is upfield zone and another is downfield zone. Upfield from it is calculated in ppm unit, that is parts per million unit. For upfield region 5 to 0, this is known as upfield region, and whereas from 5 to 12 or 15, this is known as downfield region. Now TMS, what is TMS? TMS is the reference standard in NMR spectroscopy. The full form is tetramethylsaline. It has 12 protons which are equivalent and highly shielded, so it gives only one sharp signal as singlet. So for this reason TMS is very much important and good for reference standard in NMR spectroscopy. Now chemical shift, we calculate the NMR value or NMR data by coupling constant and chemical shift value. By chemical shift value we can predict the position of the of any atom in any spectroscopy, in spectroscopic data, and from coupling constant we can predict the interaction between the two adjacent center of any molecule. Now the interpretation of NMR spectroscopy, that means what kind of information we can get from the NMR spectroscopy. The number of signals which gives us the types of different types of protons or different types of atoms present in the compound. Now positions of the peak, we can predict the what type of link is present in the molecule. And intensity, from the intensity there is different types of splitting pattern which is shown in the right side of this slide, which can give the identification about the type of proton is present in the molecule. Now the application of NMR spectroscopy, from all these three types of spectroscopy NMR gives us the most application or most information about the molecule. We can get the structure of the of any type of compound from NMR spectroscopic study, and there are so many application in medicinal chemistry, food technology, and structure elucidation in biology. There are different types of application of NMR spectroscopy. Now here I have mentioned two reference which I followed to prepare this PPT. And lastly, thank